All right, so let's start out just with a quick review with a multiple choice problem here. We've got let f of x equal the integral from 0 to x of 10 over 1 plus e to the t dt. Which of the following statements are true? Now, when you see that integral, what comes to mind? There we go, the second fundamental theorem of calculus, okay? Or fundamental theorem of calculus part 2, however you want to remember that, okay? So, you'll see the choices here. What did we do with an integral like that in our second fundamental theorem of calculus? Okay, we put the x in for t. What does that equal? How are we able to just do that?
Prime f(x)?
Yes. That's the derivative of capital F of x. Okay? That's the derivative. So, you don't just stick it in there, but you're actually taking the derivative with respect to x. Okay? Now, that will actually allow us to analyze all three of these statements and see which, if any of them, are true. I'm assuming at least one is, since none of the choices are none of these. And I'm assuming at least one of them is false, because 1, 2, and 3 is not a choice either. Alright, so let's start with the first one. This is a nice easy one. Okay? F of 0, or f prime of 0. What do we get when we do f prime of 0? It's 1 plus e to the 0, which is 1, so it's 10 over 2, which is 5. Okay, so we just proved that choice 1 is correct. Alright, so I know that B is not the answer and C is not the answer. Okay. So let's try some others here. Okay. Part 2. How would I be able to determine if part 2 is correct or not? Alright, we could plug in 2 here and we could plug in 6 here and do the integrals for both of them. Although right now we don't know how to do the integral of an exponential. There's an easier way though.
Use the first derivative of f(x)?
Okay, so how would we use the first derivative?
Because it's greater than 0.
Okay, so if the first derivative, you're saying the first derivative is always going to be greater than 0. I know that because e to the x is always greater than 0. So 10 over something positive is always going to be positive. Sorry, not greater than. Sorry. Greater than 0. Thank you. Okay. So how is that useful?
So the f(x) is always increasing.
Aha, that tells us that capital F of x is always increasing. So that means that if I have this function, wherever it is, that at 2 and at 6, the point at 6 is going to be higher than the point at 2 because I had to increase to get up there. Okay? So I automatically know 2 is correct, and by process of elimination at this point, I could eliminate A and E, and I know that my answer has to be D. Okay? Now, just to be thorough, how could I disprove number 3? F is concave upward. Okay, find the derivative again. So f double prime of x So if I rewrote this as 10 times 1 plus e to the x to the negative 1, that'll enable me to take the derivative without having to mess with the quotient rule, which would be nice. Okay? So what is our second derivative then? Negative 10. 1 plus e to the x to the negative 2. Yeah, times the derivative of the inside. That's e to the x. So we're using the chain rule here. Okay? And I can think through this. I can simplify a little bit. It's a negative 10 e to the x over 1 plus e to the x squared. Okay? Well, something squared is always positive. E to the x is always positive. But I have a negative 10 times those. So I know that this is always going to be negative. Right? Which means it's concave down. Alright? F prime of x is always concave down. Okay? F is always concave down. F prime is always going to be decreasing. Because the second derivative is the derivative of the first derivative. So I know it's always going to decrease. F is always going to be concave down. Okay? Any questions? Comments? Anything? All right. So now that we've dealt with that and we know how to deal with derivatives of exponential functions, let's look at integrals of exponential functions. All right? So if the derivative of e to the x is e to the x, what do you think the integral of e to the x is? E to the x plus c. All right, plus c. All right, so that makes sense, right? And it also makes sense that if we have an e to the u, the integral of e to the u is going to be e du is e to the u plus c. All right, so it doesn't really make sense to practice integral of e to the x. You just got to memorize that one. But let's look at some examples of ones where we do have to use this e to the u du. All right, it's integration by substitution. All right, so if I want to find the integral of e to the 3x plus 1 dx, all right, what is u in this case? 3x plus 1. And du, 3 dx, right? So, I see a dx. I need a 3 here to replace it with a du. So that means I need to multiply by a form of 1, so it's times 1/3 on the outside. Okay? So I have 1/3 times the integral of e to the u, and that whole thing is du. Remember, the alternative method is also to just solve for dx, that's du over 3, and then I can substitute that in. The integral of e to the u times du over 3, and then I pull the 1/3 out in front, and I have the integral of e to the u du. Okay? However you like to see that is fine. Either way, we've gotten here to this point, and that gives us 1/3 times the integral of e to the u is e to the u. And u is 3x plus 1. So it's 1/3 e to the 3x plus 1. And now we'll throw on the plus c. Okay? Not too bad. It's just more u substitution. Let's try another one, okay? What is u in this case? Negative x squared. So du, negative 2x dx. There you go. So I'm going to rewrite this one. I'm going to pull the 5 out in front. And I'm going to rearrange the inside a little bit. It's e to the negative x squared times x dx. However, I need this whole thing. So I need a negative 2 multiplied on the inside. So I need to multiply by a negative 1/2 on the outside, because that'll equal 1.
Where is the x go?
What?
By x.
This?
Yeah.
I just moved it over here.
Okay.
Yeah. I just rearranged things a little bit. So now that is du. And I now have the integral, or I should say negative 5/2 times the integral of e to the u du. So that's a negative 5/2 times e to the u, and u is negative x squared. Okay?
You can still do like you can put the whole thing over 2, not c obviously, because you know what I'm saying.
Oh, you're saying, I could actually rewrite this as negative 5 over 2 e to the x squared. Take care of the negative with the x and put it in the denominator. That's fine. So, since it was a negative exponent in the original problem, I can leave it a negative exponent in the answer. Okay? All right, couple more examples here. We have e to the 1 over x, e to the 1 over x over x squared. What are you going to make u equal in this case? 1 over x? X at negative 1. Okay. Basically, you've got to decide. It's either going to be a 1 over x squared or it's going to be a 1 over x. You got to figure out which one is going to be which. So we'll try the 1 over x first. Du is negative x to the negative 2, right? Well, that's kind of nice because I can rewrite my integral as e to the 1 over x times x to the negative 2 dx. All right?
Can you make the x, like x to the negative 1, and then can you multiply those and make it negative?
Wouldn't you have to multiply by?
Wait, I'm sorry, what?
Like, can you make it e to the x to the negative 1,
You can.
and then can you multiply? You know, if it's power to a power, you can multiply them?
Only if the bases are the same.
Oh, okay.
Yeah. We have a base of e and a base of x, so you can't
Okay.
in that case. That's a good question, though.
Thanks.
All right.
Do you have to multiply the outside times negative?
Yes, to get a negative on the inside, we need a negative on the outside as well. So here we have the du. Again, this comes down to a negative integral of e to the u du. So it's negative e to the u. And u is 1 over x. And then we put the plus c. Okay? So you should be recognizing a pattern. These all are pretty much the same, just turn out a little bit different in the details, okay? All right, one more. Tell you what, try this one real quick. I'll give you a minute or two here to try this one on your own, and then we'll take the take a look at the answer. All right, let's take a look at our solution here. Okay. What's u? Cosine x. And du? Good. Negative sine x dx. So what do we need? Yeah, negative. All right. Because this sine x dx will give us our du. All right. So we can rewrite this as a negative integral of e to the u du. Okay. This and this combined for the du. So that's a negative e to the u, which is negative e to the cosine x plus c. Okay? How many of you were able to get that? Okay? All right. Good. Good. Okay, one last one. Solving the differential equation. All right, we want to solve for y. So what are we going to do to solve this differential equation for y? You don't like these. Take the integral. Yeah, we've got a derivative, right? So if you take the derivative of the integral, or the integral of the derivative, okay, we're going to take the integral with respect to x on both sides. Okay? Now, the dx's will cancel out here. What's the integral of dy? Y. Because that's just a constant, right? 1. So, y equals... Now we got to figure out what to do with this thing, okay? What should we do with this e to the x minus e to the negative x quantity squared? Wait, what? Wait, what? Foil it. We can't do u substitution here because our inner function would be that e to the x minus e to the negative x. So really our best bet here is to foil it. So we have e to the 2x. We have e to the x times e to the negative x, which equals... No? What? Negative 1. Right? E to the x times e to the negative x is e to the 0. So that's going to be a minus 1 on the outers and another minus 1 on the inners, so that's minus 2. Okay?
Wait, I just want to let it What?
Oh, I see.
That's 1.
Yeah.
So you got to do your outers and your inners.
So 1 times 1 is 2.
No, 1 plus 1. Okay. All right? That's all right. So then we have e to the x, e to the negative x times e to the negative x is e to the negative 2x. Okay? So now we can integrate. Now it takes a little bit here because you have to at least, if not write it, you have to at least think of it as the integral of e to the x, e to the 2x, and then minus the integral of 2 plus the integral of e to the negative 2x dx.
Why minus 2 there?
That middle one.
Why?
Huh? Because when you multiply the outers on your foiling, and then you multiply the inners, both of those times you get minus 1. Okay. Now, what's the integral of e to the 2x?
2e to the 2x.
Not quite.
1/2.
Oh, it's it.
1/2.
There we go. It's 1/2 e to the 2x. Because look, we got to have a, for the du, you got to have a 2 there and a 1/2 out there. Okay? So e to the u du, the integral is e to the u, and you got the 1/2. Okay? Minus the integral of 2x. And then how about the last one here? Negative 1/2 e to the negative 2x. Because you need a negative 2 here to make your du, and you need a negative 1/2 out here.
Put that all plus C.
And then, yeah, at the end, we've got it all plus c. Okay? And that's all.